Welcome to Module 1, Lesson 2 of our Research Methods course, where we'll explore the research landscape, basic distinctions. In this 10-minute lesson, we're going to map out the fundamental distinctions that shape how we approach research across all disciplines. These distinctions aren't just academic categories, they're practical tools that will help you understand where your own research interests fit within the broader landscape of scholarly inquiry. As we journey through this lesson, I want you to think about your own field of study and how these concepts apply to the questions you're passionate about exploring. By the end of our time together, you'll have a clearer understanding of the choices researchers make and why different approaches serve different purposes in our quest for knowledge. Let's begin by establishing our 3 learning objectives for today's lesson. First, we'll differentiate between basic and applied research approaches, understanding how these 2 orientations shape the questions we ask and the methods we use. Second, we'll identify the qualitative-quantitative continuum in research methods, moving beyond the false dichotomy to understand these as complementary approaches rather than opposing camps. And third, we'll recognize disciplinary variations in research traditions, appreciating how different fields have developed their own methodological cultures, while increasingly borrowing from each other. These objectives will guide us through a structured exploration of the research landscape, giving you the conceptual tools to navigate your own research journey with greater confidence and clarity. Now let's dive into our first major distinction: basic versus applied research. Basic research, shown here on the left in our teal panel, is driven by curiosity and the desire to expand our theoretical understanding of the world. When researchers engage in basic research, they're asking fundamental questions about how things work, why phenomena occur, and what underlying principles govern our universe. They're not immediately concerned with practical applications. Instead, they're building the foundation of knowledge that future innovations will stand upon. Think of basic research as exploring fundamental principles, expanding theoretical understanding, and pursuing knowledge for knowledge's sake, without the pressure of immediate practical application. On the right, in our orange panel, we have applied research, which takes a different but equally valuable approach. Applied research is all about solving practical problems, addressing real-world challenges, and implementing theoretical knowledge in ways that directly benefit society. Applied researchers take the insights from basic research and translate them into solutions, interventions, and innovations that make a tangible difference in people's lives. The crucial point to understand here is that these approaches are complementary, not competing. They form a continuous cycle where basic research provides the theoretical foundation that applied research builds upon, and applied research often reveals new questions that send us back to basic research for deeper understanding. Let me illustrate this distinction with concrete examples across different disciplines, which you can see in this comprehensive table. In physics, basic research might involve exploring string theory or quantum entanglement, investigations into the fundamental nature of reality that may not have immediate practical applications, but expand our understanding of the universe. Meanwhile, applied physics research focuses on improving solar panel efficiency or developing new materials for electronics, taking physical principles and turning them into technologies that solve energy and communication challenges. In psychology, basic research examines how memory formation works at the neural level or how cognitive biases develop, while applied psychology researches therapy, effectiveness, or develops interventions for specific mental health conditions. Biology shows this distinction clearly too. Basic research investigates DNA replication mechanisms or protein folding, while applied biology develops vaccines or creates drought-resistant crops. In economics, basic researchers develop theoretical models of market equilibrium or game theory, while applied economists analyze policy impacts or forecast economic trends. And in education, basic research might explore how learning occurs in the brain or what factors influence motivation, while applied educational research tests curriculum effectiveness or develops new teaching strategies. These examples demonstrate that every field benefits from both approaches, and the most significant advances often come when insights from basic research enable breakthrough applications. Moving to our second major distinction, let's explore the qualitative-quantitative continuum. Notice how I'm presenting this as a spectrum rather than a dichotomy. This is intentional and important. On the left in blue, we have qualitative approaches that focus on words and meaning, seeking deep contextual understanding through rich descriptions of human experiences, cultural phenomena, and complex social processes. Qualitative research asks how and why questions, diving deep into individual cases to understand the nuances and complexities that numbers alone cannot capture. In the middle in purple, we see mixed methods as an integration point, offering comprehensive triangulation by combining the depth of qualitative insights with the breadth of quantitative patterns. This approach recognizes that some research questions are best answered by leveraging both perspectives, using qualitative data to explain quantitative findings, or quantitative data to test theories developed through qualitative observation. On the right in red, quantitative approaches work with numbers and patterns, using statistical analysis to identify trends, test hypotheses, and produce generalizable findings that can be applied across populations. The key insight here is that your research question should drive your methodological choice, not the other way around. Some questions demand deep, contextual understanding that only qualitative methods can provide. Others require the statistical power and generalizability of quantitative approaches. And many benefit from the comprehensive perspective that mixed methods offer. Let's make this even more concrete by matching specific research questions to appropriate methods. And I'll show you some data on how researchers are actually using these approaches. When we ask, how do patients experience pain? We're asking a fundamentally qualitative question that requires understanding subjective experiences, personal narratives, and the meaning people attach to their suffering. Numbers alone cannot capture the lived experience of chronic pain. Conversely, what percentage of students pass is inherently quantitative, requiring statistical measurement and numerical analysis to provide a definitive answer. But consider, is the program effective and why? This mixed methods question needs quantitative data to measure effectiveness and qualitative insights to understand the mechanisms behind success or failure. The chart on the right shows that in contemporary research, we're seeing increasing use of mixed methods approaches, with about 40% of studies now incorporating both qualitative and quantitative elements, while 25% remain purely qualitative and 35% purely quantitative, reflecting a growing recognition that complex problems often require multiple perspectives and methodological flexibility to fully understand and address. Now, let's examine how different disciplinary traditions have shaped distinct research cultures. Though these boundaries are becoming increasingly permeable, the natural sciences, shown in green, have traditionally emphasized experimental methods, hypothesis testing, replication, and objective measurement. This tradition values controlled conditions, mathematical precision, and the ability to isolate variables to establish causal relationships. The social sciences, in blue, commonly employ mixed methods because human behavior is complex and contextual, requiring both the statistical power to identify patterns across populations and the interpretive depth to understand why people act as they do. Social scientists have developed sophisticated ways to study phenomena that can't be brought into a laboratory, using surveys, interviews, observations, and increasingly sophisticated computational methods. The humanities, in purple, bring interpretive analysis, critical approaches, and textual methods to bear on questions of meaning, culture, and human expression, recognizing that not everything valuable can be measured or quantified. What's exciting about current research trends is the emergence of transdisciplinary approaches that break down these traditional boundaries. Digital humanities. Scholars use computational methods to analyze literature. Neuroscientists collaborate with philosophers to understand consciousness, and climate scientists work with anthropologists to understand human responses to environmental change. The value of methodological diversity cannot be overstated in our current research landscape. As this slide emphasizes, different questions genuinely require different approaches. There's no single best method that works for all research problems. When we embrace complementary methods, we strengthen our collective understanding by approaching problems from multiple angles, each revealing different facets of complex phenomena. Innovation and diversity in our methodological approaches leads to breakthrough insights that wouldn't be possible if we remained locked in disciplinary silos. Most importantly, we must move beyond methodological tribalism, the unproductive debates about whether qualitative or quantitative methods are better, and instead focus on selecting the right tool for each specific research question. The most impactful research today often comes from scholars who can skillfully navigate multiple methodological traditions, choosing and combining approaches based on what will best answer their research questions, rather than adhering rigidly to disciplinary conventions. Before we conclude, I want you to engage in a self-reflection activity that will help you connect these concepts to your own research journey. First, consider where your research interests fall on the basic-applied continuum. Are you more drawn to understanding fundamental principles or solving practical problems? And importantly, why does that orientation appeal to you? Second, think about which methodological approaches feel natural versus challenging to you. Do you find yourself gravitating toward numbers and statistical analysis, or are you more comfortable with interviews and textual interpretation? And what might you gain by developing skills and approaches that currently feel less comfortable? Third, reflect on how the research traditions in your discipline have shaped your thinking about what constitutes valid inquiry. What assumptions have you absorbed about proper research methods, And are there opportunities to expand your methodological toolkit by learning from other disciplines? Take time to journal your responses to these questions, as these insights will be invaluable as you develop your own research philosophy throughout this course. Let me leave you with 4 key takeaways from today's lesson that will serve as foundational concepts for your research journey. First, research exists on multiple continuums, basic to applied and qualitative to quantitative, and your position on these continuums should be determined by your research questions, not by rigid adherence to tradition. Second, different disciplinary traditions shape methodological preferences, but these traditions are increasingly fluid and permeable as researchers recognize the value of methodological pluralism. Third, methodological diversity strengthens our collective understanding by allowing us to approach complex problems from multiple perspectives, each contributing unique insights. And fourth, your philosophical position about the nature of knowledge and reality will inevitably influence your methodological choices. So developing awareness of your own assumptions and biases is crucial for conducting rigorous research. As we move forward to Lesson 3 on the concept of research paradigms, remember that these basic distinctions we've explored today form the foundation for understanding the deeper philosophical frameworks that guide all research endeavors.